Welcome to Lesson 2.2 Secure Data Lifecycle. In the AI ecosystem, data is the lifeblood, but also the primary attack surface. The secure data lifecycle defines how organizations collect, store, process, and ultimately dispose of information responsibly. In this lesson, we will discuss the stages of the secure data lifecycle from collection to deletion, how it applies to both structured and unstructured AI data, how lifecycle thinking ensures continuous protection, and the policy alignment with business and regulatory goals. So let's get started. So, secure data collection. Security begins at the point of collection. Overcollection not only increases risk, but often violates compliance standards. Data minimization, data minimization, collecting only what's needed, reduces exposure. Consent mechanisms, especially for personal or biometric data, must be explicit and logged. Provenance tracking ensures data sets haven't been tampered with or poisoned before training. Secure ingestion means validating data origins and using encrypted APIs or message queues to prevent injection attacks. A trustworthy AI pipeline starts with authentic, ethically sourced, and tamper evident input, laying the foundation for integrity and fairness downstream. Secure storage and encryption at rest. Once collected, data security depends on robust encryption at rest. Proven algorithms like AES 256, backed by enterprise key management systems, safeguard against theft or unauthorized access. However, encryption is only as strong as its key governance. Rotate keys regularly, enforce split key custody, and separate duties. No single admin should both store and decrypt sensitive data sets. Implement granular access control based on the principle of least privilege, ensuring analysts, engineers, and AI developers can only reach the datasets essential to their roles. In modern AI infrastructures, storage encryption and access governance are inseparable pillars. Secure processing and encryption in use. AI data must remain secure even while being processed. Traditional encryption protects data at rest or in transit, but encryption in use is the next frontier. Trusted execution environments, or TEEs, such as Intel SGX or AMD SEV, isolate computation so that data remains encrypted even while processed in memory. Masking and tokenization prevent sensitive identifiers from leaking during analysis or model training. Combined with strict runtime authorization, these techniques ensure data confidentiality doesn't vanish once computation begins, a critical safeguard for AI workloads that process vast, highly sensitive datasets across distributed cloud and edge environments. Encryption in transit and data flow security. Data in motion is often the easiest to intercept and therefore demands strong transport security. Enforce TLS 1.3 for all communications and use mutual TLS or MTLS between AI services for authenticated encrypted channels. Payload signing guarantees data integrity between producers and consumers. Beyond encryption, monitor for exfiltration indicators such as abnormal API calls or data volume spikes. In AI pipelines, microservices exchange high value data continuously, telemetry, model outputs, and embeddings, each a potential leakage path. Continuous encryption and observability ensure that even transient data remains secure during its journey across networks and environments. Data retention and deletion. The life cycle ends with deletion, but this phase is often neglected. Data retention should follow classification based timelines, short for temporary logs, longer for compliance records. Automate deletion workflows and log every removal for accountability. Ensure that purged data is erased not only from production systems, but also from archives, caches, and cloud backups. Compliance with privacy mandates like GDPR's right to be forgotten or AI Act retention clauses require demonstrable evidence of destruction. In mature AI governance, deletion isn't a one time event. It's a verifiable, controlled process that closes the loop on secure data stewardship. Logging and audit enforcement. Logging acts as the connective tissue across the entire lifecycle. Every data access, modification, and deletion should generate an auditable event, timestamped and linked to verified identities. Immutable log storage, whether via append-only systems, blockchain blockchain-backed archives, or centralized SIEMs, ensures tamper evidence. Correlating these logs with telemetry from AI systems enables both operational visibility and regulatory compliance. Mature AI environments treat logs not as optional but as enforceable controls, empowering rapid incident response and long-term accountability for every data action performed within or around the model pipeline. And now for the key takeaways. The secure data lifecycle protects AI trust end to end. Encryption, access control, and logging work in unison. Automation enforces consistency and compliance. And finally, security must evolve with data and models.